Now, let's start on it. Okay. One. One. Tab. That. There. Yeah. Yeah. Can folks hear me okay at home? Thank you. Appreciate it. Okay, so it is 15 after, so we should start. I'll stop the sharing for a moment, and we'll come back to the exam here in a hot second. Battle plan today is to talk about the take-home exam, which I posted last night, which is due Monday night. There's not an assignment to turn in yet. That needs to still be done on my part. I'll do that today. So the problems to solve are there, but there's no place for you to turn it in yet. But I'll fix that as soon as I can. And then that'll show up on your to-do list in Canvas and all of that sort of stuff. So we'll go over that and see if there are questions about that. And then we will talk about the in-class exam on Friday and talk about what kinds of things might be on that, and give everybody a chance to ask questions about that. And then if there's any time after that, we can start talking about one other thing that we haven't gotten to yet on pictures, but I kind of doubt that we'll have any time, but I could be wrong. I mean, it depends on how many questions there are. And so I would, again, strongly encourage everybody to ask as many questions as possible, both online and here in the room. And especially for the online folks, sorry about that, there was kind of earthquake shake there. On a small laptop screen like I'm using, it's hard to have all the different parts of Canvas and all the different parts of Zoom and the Canvas window on the screen where I can see them all. So I may not see you raise your hand or otherwise try to get my attention. So in the end, just feel free to shout and we'll make it work. Because I want to make sure you feel like you have a chance to ask questions. So, are there any big picture questions before we start talking about the exam? Going. Oh, and I guess I have an experiment today. I ordered some sort of silicone frames that go inside your mask and keep it off of your mouth. And the hope is that it would make me less muffled. I don't know that that's actually true, but if you feel like this improves or makes worse how I sound in class, let me know. If you're like, whatever, don't care, that's fine too. But it was like a thing somebody said online helped them. So I was like, oh, we'll try that. Okay, so let's run over to the exam take-home component. Okay, so as a reminder, you can ask me all the questions you want. So start early and ask lots of questions. Don't feel like you need to bang your head on stuff and that there's some prize for having suffered the most. There is no prize for having suffered the most. The prize is like understanding and showing that you understand. So start and ask questions. You can ask questions in class, especially sort of questions of clarification. You wouldn't want to be like, here's my code, what's wrong in class? Because that would kind of give everybody the answer. You can use Slack, you can use email, but I'm here to help. So definitely ask questions. I'm getting an enormous amount of email at the moment, and I'm having a hard time managing it. If you send me email and a day has passed and you haven't heard anything, or 12 hours passed and you haven't heard anything, feel free to send me another email and bump it up my queue because I might have just missed it. There are 4 problems. The first 2 are string problems. The second 2 are picture problems. Problem 2 is manipulating color. And problem 4 is actually mirroring pixels, like we talked about in class, although this will be slightly different. Okay. So the idea of the first 2 problems go together. They together solve a larger problem. And the larger problem is this idea of right-adjusted string. And the idea is that you could call right-adjust with a string, and it would split that string up into words, and then it would print them right-adjusted. Like if you just printed each word normally, they would be what's called left adjusted. The left edges would all line up and the right edges would be ragged, okay? The right edges would move back and forth. Here we're switching that to be right adjusted. So the right edges line up and the left edges are ragged and move back and forth, okay? And I've given you right adjust right here, but it depends on 2 things that we don't have, max length and pad right. So your job in problems 0 and 1 are to write, respectively, max length and pad right. Okay. And max length is supposed to compute the length of the longest word in a list of words. So given a list of words like this, it should compute the length of the longest word. So in this example, that would be 10, since the word manipulate has 10 characters. Okay. And then pad right takes the length of the longest word and a list of words and prints them out in this form. Okay. Does that make sense? Questions about that? So max length. Oh, I have made a mistake here. These examples don't have lists of words, they have strings. Oh, bad me. Let's edit that right here and fix it. So max length is supposed to take a list of strings, and I'm giving it a single string in this example because I boo-booed, and that was bad. Oops, stop it. And then close bracket, and then one more, open square bracket, quote, comma, quote, quote, comma, quote, quote, comma, quote, quote, comma, quote, quote, comma. Almost done. There we go. And that's what one of those. Yeah. Say that. So if you're following along at home, if you reload the page, it should have the corrected example now. So max length takes and you can assume it's that the list is non-empty if that helps. It's not entirely clear what to return if you ask for the largest of a list of no strings. So if it's useful, you could, yes, Joseph. I do on that last example. Good catch. Thank you. That's why we need a village to write an exam, apparently. There we go. Is that the example you were concerned about? Okay. Good catch. Thank you. All right. So if the list has one string in it, then the max should just be the value, the length of that string. In the case of University of Minnesota Morris, university has 10 characters. Minnesota has 9, I think. 4, 5, 6, 7, 8, 9. Yeah. So the longest is university, so we get 10. And then if we have Nick McPhee is the instructor for CSci 1201, instructor is the long one here, and it again has 10. So 10 happens a lot. Nick looks like Nick maybe has a question. Nope. Good. So that's your job for problem 0. Are there questions about what to do for problem 0? Any questions at home? Okay. Then pad right. And again, I'm supposed to have lists here. Man. Okay. We will edit this again because it's such fun. In fact, on this last one, I'm just going to copy paste because that'll be easier than me trying to fix it all. The others are pretty short. So this should be a sequence of strings. This should be a list of strings. Da, 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 da. Oops, no comma, not M. Oh, again, thank you. Ah, what is going on? Ah. And then, oh, and I need a close square bracket there. And then I just need brackets for this. Da, 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 da. Boom. That's better. That's better. There we go. So pad right takes two arguments. The first is a number, which is the length of the longest string in the list of characters or list of strings, and then a list of strings. And it should print all those strings in the list, right justified. So the length of each thing that is printed should be the same as the first argument, the longest string. So when you only have one string, it's just Morris and you're done, okay? Or if there was just the string frog, then it would just be frog and you would be done. When there's a set of strings, then you need to add spaces to the front of all the strings that are not as long as the longest string. So let's take the last case here. The longest string is length 10. My first name only has 3 letters in it. So I have to put 7 spaces here, followed by my name. And that's going to give me a total of 10 spaces. And McPhee has 6 characters, so I'm going to need to put 4 spaces, followed by my name, to get a total of 10 spaces. Or 10 characters, okay? Does that make sense? Any questions at home? Okay. Now, note that whether things will actually line up correctly in Jest for You depends on the font that you're using in your command area. So here, I'm going to pull up Jest and jump out of sharing the canvas for a second. Excuse me. So like if I say, oh, here, we'll just do the example, print frog, print, let's see, yeah. Print. So up in the top, those all line up. Now it'll load. It's going to ask me to say here, CSci. I want to go into 1201. Yeah. CSci 1201, 2020, 09, 23. Today's my wife's birthday. So if we load that, and we run example, for me, this lines up. This lines up in part because I have chosen a under options on Windows, I think it's preferences on a Mac. you can choose your command window theme down here, and the default, so standard on black, I think this is the default that you get. Now, if I say example, oh, that actually worked. Hang on. Is there something else I needed to change? Or not? Oh, it's old Jess. So I think, yes, old Jess is what it started out as. And in the old Jess theme, the characters have different width. So characters like I are very narrow, and a character like M is much wider. And so all these alignment things, like the pyramid example from chapter 3, don't really work right if you're using that theme. But if you choose one of the other themes, most of them have fonts that all letters have the same width, and then the alignment stuff will actually look right. So, oops, I didn't mean to do that. So if I go back to colorblind friendly, oops, I meant to do on white. Colorblind friendly on white. Now these line up correctly because all the characters have the same width. An M has the same width as an I, has the same width as an L. And so everything will line up correctly. So if you want, you can solve the problem without messing with this, but if you want the visual feedback, it's probably useful to change your theme for your command area to make sure you're using a font that has a uniform character size. Questions about that? You good at home? Awesome. Thank you. Okay, then let's go back to sharing the canvas. Okay, so are there any questions about max length and pad right, the two string problems? Are we good on both of those? Questions anywhere? Okay, going. Then let's roll down. So the next problem is about fading images. So what we're doing here, I'll actually scroll down to an example, a couple of examples. So here we are taking original images and fading them in a sort of cheap version of what would happen to actual printed photographs. You may have seen that printed photographs tend to fade over time. And so we're mimicking that idea here. If we really wanted to be fancy about it, it turns out that different dyes in photographs fade at different rates. Turns out yellow tends to break down faster than the other colors. So that's part of why old photographs, the color balance seems weird, like they seem too pink a lot of times. And it's because like the yellow and depending on the brand, sometimes the blue, those break down faster. We're not going to worry about that. We're just going to fade everything equally. And we're going to fade it using a very simple formula. If old color is a red, either the value of red, green, or blue, okay? So it's a number between 0 and 255. We're going to divide it by 2 and add 128. So what happens if we do that? So old color was between 0 and 255. When we divide it by 2, it becomes between 0 and 127, right? That sort of drops it from going all the way up to 255 to going no higher than 127. Does that make sense? Now, if you think about it, that's going to make the picture a lot darker because low numbers are darker than high numbers. But photo prints tend to fade to white, not to black. You could imagine a different sort of chemistry where they would fade to black, but it's not actually how it works with the way most printing happens. Printing tends to fade to white because the dyes break down, and without the dyes, everything becomes white. It's the dyes that make things non-white. So then we add 128, and that shifts us back up to the range 128 to 255. So we've gone from 0 to 255 to 128 to 255, and we've made everything brighter and closer together, which has the effect of looking like we're fading the image. So the image becomes brighter, and you particularly notice it in dark areas, right? This very dark blue here becomes kind of a weird bluey gray. So it becomes lighter, and things that used to be really different become closer together. We pushed everything into a smaller range. Okay, and that's just a lot of noise to explain what to do or explain why I'm doing it. All you really need to understand is that you take red, divide it by 2 and add 128, blue, divide it by 2 and add 128, green, divide it by 2 and add 128, reset the pixel to have that new color, and then you're done. Okay, do that for all the pixels, and you get this, faded version of the world. Okay, that should be pretty straightforward, and you can use these examples as comparison points if that's useful. Okay. The one other thing is that fade color should act in place. So if we give it an image, it should modify that image so that after we call fade color, if we call show on that image, we ought to get the new faded version. And if we call fade color on part and then call show part, we should get the new faded version. So this doesn't return a picture, it modifies the picture it's been given. Okay? Questions? Any questions at home? Oh, my thing's falling apart here. I didn't even realize. I feel like they're walking around with fly-ins or something. So, okay. I don't know, maybe this brace thing is not going to work as well as I'd hope. Questions? Okay, not hearing any. Last problem. So here we're going to mirror right to left. This is very similar to, but not the same as the examples that we did earlier in class. In class, when we mirrored, we would take a picture like this and we would mirror on the right edge. So the stuff on the far left would sort of go over to the far right, or the stuff at the top would go down to the bottom. Here, I'm having you mirror on the left edge. So the stuff on the right kind of flips over to the far left, which has a particularly nice effect on this picture, right? So I'm using, because then you get these, it turns this half gate into this kind of weird double gate effect, okay? And so the math on this is a little more complicated. It's not a lot more complicated, but you're gonna have to think about it some. And this would definitely, this is the last problem, but I wouldn't wait to think about the math until the last minute on this, because this could be the kind of thing you might have questions about. And having thought about this early enough that you can ask about it would be a good idea. And so the idea is that this will take a single picture as an argument. It will return a new picture, which it has to because the new picture is going to be a different size than the original picture. The new picture should be twice as wide as the original picture and have the same height. And then we want to copy the old picture twice into the new picture. One copy should go on the right-hand side as is, okay? Notice that that's going to need to be shifted over, though, to end up on the right-hand side and not on the left-hand side. You're going to have to shift it when you copy it. And the other copy is going to be flipped backward. So you're going to have to modify the X or Y coordinate so that it gets flipped when it's copied into the left-hand side. So this is probably the most complicated, at least in terms of you're going to have to work some math out, problem on the exam. Okay, well, I'm completely falling apart. This is just not working. Momentary pause. There we go. We're just going to get rid of it. Okay. So you're going to have to work out the math and make sure that you're copying the correct parts into the correct places. It'll be pretty obvious if you're right, but there's going to be a lot of potential for errors where you went off the edge of a picture somewhere. And that could be something you could spend a lot of time banging your head against. And again, I can help with that sort of stuff if you have a question. And this is going to have to return a new picture because the picture that you're making is bigger than the old picture. And so we're going to have to call on a particular image and generate a new picture, which then if we show should look like this top one here, or here's another example using the fallen tree picture. So again, the original ends up on the right as it was, and then is reflected on the left. Whew. So it's a lot of stuff. Are there any questions from anybody about any part of the exam? Any questions at home? We good? Awesome. Okay, we'll call that a win. So I'm done talking about the take-home part of the exam at the moment. Unless there are any questions, quickly, we will close this. Stop sharing. Okay. Then let's talk a little bit about the in-class part of the exam. So that will be structured as a Canvas quiz, which we will do during the class period on Friday from home. I will not be here in this room. I will be online. You can come to this room and take the exam if you want. I don't care. You can be wherever you want to be, but we'll do the exam during the scheduled class time on Friday. The exam will be a combination. Oh, actually, let me go back to sharing this. So I've got a place I was making some notes to share with everybody. There we go. That's what we want. So, so the exam will be structured as a Canvas quiz. There, whoops, can't spell. There will be multiple choice, matching, and simple answer sort of text box. The first two will be automatically, the first two types will be automatically graded by Canvas. I'll have to grade the simple answer problem. So don't freak out. If Canvas, like if there were 3 problems, there'll be more than 3, but if there were 3 problems, one of each type, and you got them all right, Canvas would know right away you got the first 2, but it wouldn't know what you did, how you did on the last one. And I'm not sure how this is going to go. It keeps changing, but there has been a time in the past where Canvas is like, hey, you got a 66% on the exam. And you're like, whoa, I didn't think I did that bad. And all it's saying is that on the things I know, I can give you 2/3 of the point. And I just don't know about the last one. And so it gives you feedback that kind of can be a little terrifying because you're like, I know I did better than, a 66%. Or at least I hope I did better than a 66%. And so don't freak out, look at what it's actually saying and not just any numbers that it gives you. But it should give you feedback on the multiple choice and the matching when the exam is over right away. And then I'll have to grade the other two or the other time. Okay. So the thing I'd like to do, actually, because we got time, is I would like everybody to take like 5 minutes and come up with 3 or more. You can come up with more if you want, but 3 things that you think might make sense on the exam. So these could be general concepts, like what is a algorithm? These could be specific things like, what are the parts of an assignment statement in Python? But given what we've done so far, the reading you've done, the programming you've done, the things we've talked about, what are 3 things that might make sense on the exam? And then we'll go around and we'll get some feedback from people. So let's see, it's 47 on my watch. So let's say we'll go to 52 and then we'll hear from people. And that takes care of that. So, get rid of that. Come back here. So, somebody want to volunteer a topic? You don't have to share all three, just share one. In the room or online, don't care which. Otherwise, I'll pick on people. And I can pick on people the best. Darren, give me a thing.
I'd say exactly what a certain process does, like for example, like mirror or grayscale, or one that might be in the later chapters, I guess, like negative, I guess, and explain what it does.
So kind of like, what does an example function do? That kind of thing? Is that what you're saying?
Yeah.
Okay. So that could be like, convert to grayscale or negative or sepia or etc. Oh, that didn't work. Yeah. Okay. So there could be a bit of code, and your job is to sort of figure out what it does. There wouldn't be anything super complicated, but it certainly could be the case that you could have a piece of code and be expected to figure out what effect it has. Okay, so that would be a plausible thing. I don't think, like, it wouldn't make sense to try to memorize all the examples in the book. I think that would be sort of insane.
Mm-hmm.
On the other hand, doing the examples in the book is always a good idea, so that you understand what's going on. And the more you understand them, the easier it will be to understand an example that shows up on the exam. So I think that would be, that's a great example. Somebody else. How about somebody who's in the room? How about Henry? You're not Henry. You are, just a sec, don't tell me. I've completely lost it. My apologies. You're Josh. Das, right? Okay. So I'm picking on Josh, not Henry. I don't think Henry's actually. Oh, Henry's online. I should have even known that. So Josh, so give us an example. Now, when you say know what a program does, were you meaning kind of the same thing that we just got from Darren, or something different? Okay, yeah. So what does a function do? Sort of what role do functions play? That could be a good thing. So like, why do we bother writing functions? I can write that down. Why do we bother writing functions? And people should feel free to ask questions about any of these as we go along. Because if you're like, I don't know what role functions play, like that would be a great question. Nick. Sure. So we can have binary. So that could include, binary to decimal, bits versus say bits and bytes. How many patterns can we make with n bits, et cetera, et cetera. Yeah, all of that stuff would be possible. Nothing super complicated because, again, it's an in-class exam, so it's not like I can give you some huge binary number and ask you to convert it to decimal, but yeah, that could be a thing. Other ideas, questions? Oh, actually, there's stuff in the chat. I should look in the chat. Oh yeah, Dongting shared some stuff. Oh yeah, how do we write comments and why would we write comments? That's a good one. Dadgummit. How do we write comments? Oops. In Python, why would we write a comment? Somebody else. Joseph. Sure. Understand or explain. I like that word to use. The components of an if statement. So that would be like the if, the else, elif, use of colon, that kind of stuff. Yeah, I think that would be great. So now I'll pick on Henry, since I tried to pick on Henry and failed because I had my people confused. So Henry, what's something you had?
I didn't really have anything. I don't know.
Okay. How about Molly? Molly got something. No. How about Thomas? Nope. How about Zeke? Yeah, it seems to me like for loops are a pretty major piece that needs to be on here. So this would be a natural companion to Joseph's question about if statements. So explain the components, and I should say maybe components and use of a for loop. So in both cases, like why would we use something like this? So why would we use an if statement? Just I'm actually asking the question. So somebody, why would we use an if statement? If statement. Yeah, right. I realize that's like gets a little vague there, but yeah, right. If there are multiple conditions and we need to do different things depending on circumstance, right? So I can even say that. So used when there are multiple conditions and we need to do different things depending on circumstance. So we've seen situations where if the color of a pixel has a certain property, then we do one thing to it. And if the color of that pixel has a different property, we do a different thing to it. So like in the example where I made the clouds purple, I was looking for pixels that looked like cloud pixels, and only cloud pixels got purple, like purple or pink. The other pixels got left alone. Okay. So when would we use a for loop? When does a for loop matter? Anybody? Nick.
Repetitive process. So we need to do something to a large number of things. That could be like every pixel in an image, or it could be like an individual thing in a list.
Yep. Where we need to do the same thing to every item in a collection or a list. For example, every character in a string, every item in a list, every pixel in a picture. So if we ever need to do something to every item in a set, collection, list, thing, for loop is going to be the tool to go to there. Other things, suggestions from people. Joseph. Yeah, so there's a larger question of the use of indentation in Python to delineate, I can't spell, delineate blocks of code. And then a particular example, which would be quite nice, is two programs that are the same except for their indentation. How does that change their behavior? Yeah, that would be a really nice little problem. Other things from anyone? Anybody? So I've got a few. So I think that it's going to be important to understand RGB. So what are the components of pixel in terms of RGB? And it would be good to understand how grayscale and RGB interact. So as a simple question, how can you tell if a pixel is going to be a shade of gray or not? If I give you the RGB for a pixel, how do you know if it's going to be like a colored pixel or a black and white grayscale pixel? Yeah, if the RGB components are exactly equal, it will absolutely be a grayscale picture. If they're close, or that grayscale pixel, I should say, if they're very close, it will be a nearly grayscale pixel. It might have a slight hint of red or green or blue, but it'll be close, okay? So the strongest colors happen when the red, green, and blue are, at least one of them is fairly different from the others. So that would be a thing. Range hasn't come up. And I think range is something that could certainly be important. So what does it do? Wow, man, I cannot spell today. And I guess related to the RGB is, what are pixels? So we have to kind of understand how pixels form a picture, and that a pixel is a picture element, and it has a red and green and blue component. Like all of those things are going to matter. And, I think basic things like what is an algorithm? That's a kind of a standard question on an exam like this, because part of the deal is to understand at least some basic ideas in computer science. And there is little more basic than the idea of an algorithm. It's pretty fundamental to the deal. So being able to provide either a short answer for like what is an algorithm, or recognize an algorithm and a definition in a matching problem would be something you'd want to be on top of. Questions? Other things? So does anybody have any questions about any of these things? Like if these things were all going to be on the exam on Friday, and they probably won't all be on the exam because I think that would be an insanely long exam and I don't want to kill people. But if these things were all going to be on the exam on Friday, and I'll link to this on the front, and I'll post an announcement with a link to it as well. But if there was anything, is there anything on this list that you are like, man, if that showed up on the exam, I would not be a happy camper. I'm not sure I would know what to do or how to deal with it. Ask away. Mm-hmm. Or questions about the take home? Yes, Nick.
Questions for the in-person stuff
Mm-hmm.
or in class stuff. So are we going to be in a Zoom call while we're taking it?
So yeah, I'm not gonna like watch you. I mean, I guess there are faculty that have like said you have to have your camera on, and I have to make sure that your roommate's not taking the exam or something. I am not gonna go down that road. That seems like chaos and strange to me. But there will be a Zoom meeting and I will be there. And if people have questions during the exam, we can duck into a breakout room. So there'll just be the two of us. So you can ask your question without sort of interrupting everybody, and then we can come back. So on the exam day, if you, raise your hand in the Zoom tool, then I can invite you into a breakout room. We can talk, and then you can pop back out. after we're done. Does that make sense? So thank you. Good question. So I will be there to answer questions. And I'll also be looking at Slack. So if you want to DM me on Slack with a question, I can certainly help with that as well. But if you've got, yeah, I mean, so either way, it's fine by me. So I think you said you had 2 questions.
Yeah, the other one was you did submit before the end of the hour.
Yeah. So it'll be a quiz, and you'll have until the end of the hour to turn in the quiz, to finish the quiz. And I'll try to announce sort of time breaks at like half an hour and 15 minutes left, stuff like that. Enough to be useful, but not so many to be annoying, hopefully. So. Other questions? Going. So we only have 6 minutes left, and I don't there's not something really terribly useful I can do in 6 minutes, I don't think. So if there are questions, I'm here to answer them. But if there are not, we could just be like done, and everybody gets an extra 5 minutes of their life to spend doing however they see fit. Okay, I think we'll call it good. Anything at home? Are we happy? Happy people? Okay, seeing some thumbs. Happy, good. Then I think we will call it quits. I will stop sharing this. I will link to that page and share that out. Otherwise, I will see everybody online Friday, and we'll do an exam and be done. And if you get questions about the take home, definitely ask. Thanks a lot. We'll see everybody later. Ciao.